Okay. Okay, so let's think through this mathematically, and then we'll talk about the shortcut. Okay, so this reaction is the original reaction flipped in reverse. So if I do a reaction backwards, what is that going to do to the K? Yeah, reciprocal is the right math word, right? So the K for this, once again, would just be the opposite or the reciprocal of what we had, because the reactants are now the products and the products are now the reactants. So of course you could write it all out again and then plug in your numbers to get your value. Or if you just do the inverse of what you already have, or the reciprocal of what you already have, that will give it to you as well. Which, once again, these are just shortcuts you can use when an equation changes just slightly. Okay, so here's our generic example. So here's the forward reaction, so that's why it says F, is because we're saying it's going forward. If I reverse the reaction, Kr is going to equal 1 over Kf. So to find this, you could just take 1 divided by 4.36, and you get your answer. 0.229 or 22230, I guess, because of rounding. Once again, it's not that hard to plug the numbers back in, but when you're dealing with time, which is always a thing on AP test, any shortcut can help. So, does that make sense though mathematically why that works? Yeah. Because if you're just flipping the products reactants, in a sense we just do the same with the K. Okay, next shortcut. So once again, look at the equation we just had. Now look at the next equation here. So if I multiply everything in the reaction by something, in this case we times it all by 1/2, but same thing, you could double them or triple them. With our enthalpy when we did this, so let's write our new K value for this reaction. So the Kc, once again, is always products over reactants. So we have SO2, O2 to the 1/2.
So it's still flipped. It's just...
Yeah, because so it's been flipped from the original and then halved. So with delta H, what happened with delta H, like with Hess's law? If we times all of these by 2, what happened to the delta H? It also got times by 2, right? But in this case, because the coefficients become powers, it just becomes the power of the original one. So this would just equal, what did we have, 0.2230? So if I just take that to the 1/2 power, that will give me my new K value. Thank you so much.
Yeah, there's a lot.
I don't know what this is.
That's a lot of orange.
Is that for us?
No,
Okay.
we're on purple, not orange. They're on the orange unit, so. I don't remember the answers. 0.46. 480 with rounding. So. Okay. So once again, you could plug in the numbers and you would get this. Or you can just shortcut it if you already have a K. Now once again, the way like problem-wise that you would know this is what you need to do is the problem would have already given you K values. Right? If you don't have any K's to begin with, then of course you have to find them. But if you already have a K, then sometimes you can just manipulate it. So the last type of manipulation is when you combine reactions together. Okay? Oh, here's our generic example. So once again, when you times an equation by some variable, which I'm just saying is n, then this one would just be K1 to the power of n. Once again, the 1 and the 2 are just designating the different reactions, right? Just so to mix them up. Okay, so finally, I'm going to move that off that line a little bit. That's better. Okay, So if we have two reactions here, this is supposed to be just a solid line, by the way. And let's say we already know the K for this. Once again, I'm just going to call it K1 and K2. And the goal is to find the K for this overall reaction. Yeah, Bonnie. Oh, I don't know. Probably not.
Oh.
Let's write it over here. K1, K2, and we're trying to find K3. Thank you.
Why is S like
She said right on the board so that way the people.
Because if I go into the shadows, the camera can't see.
wait?
She's saving them again.
Why is it HS negative negative and then H plus minus?
I think this was supposed to be a solid line, and for some reason it just like underlined them. So it's underlining the powers.
They're
Double
negative.
negative, it's
Yeah,
power.
the format of that's really
Plus
weird.
or minus H, 'cause you don't know. Plus or minus H.
Yeah.
equals.
Like if we're not sure on a question, can we just do plus or minus?
Plus or minus.
Plus or minus a charge? I don't think so. Not if you want points. Okay, so here's my overall, once again, because that cancels out, right? So if I want to find K3, now once again, let's connect it somewhat. So with Hess's law, what did I do to find the overall heat? You just added them together, right? Heats are additive. In this case, we don't want to add because of the setup of K's, but you multiply. So K3 is going to equal K1 times K2.
Even with the intermediate.
Yep, because if you actually set up the, like, what K1 would be, so K1 would be H plus, and then HS minus, right, over H2S, and then K2 would be H and S over HS. And so if you times those together, the intermediates cancel even in the K's. And then the H's would combine to be squared. Like they are there. So, yeah, Connor.
Is this because the temperatures are real temperatures and this is a probability? That's why we're multiplying it?
We're multiplying because, maybe think of it more as because they're ratios, right? Because like K is a ratio of products to reactants. And so same thing here, K3 is a ratio of products to reactants. So we look at K3 would be H plus squared, and then that over H2S. So if you times these two together, it is that. Does that make sense, kind of, if I write it out that way? Great question, though, or comment. Questions on that? Once again, it's just a shortcut. If you already have these, you've already done the work to get them. You don't have to do a third Rice chart to find this guy. You could just times them together. Yeah, and then up here.
How would you find the polarity of those? Did the problem give it to you?
So that's the catch, is if you already knew these, like you already knew what K1 equaled and K2 equaled, you wouldn't need the molarities of the third one.
Okay.
You could just times K1 by K2. So, does that make sense? So here's, my generic example. So, K3 just equals K1 times by K2. And that's what your quiz 7.6, the one quiz we have for today, that quiz is practicing all these manipulations. Is it will give you one, and then it will say if I flip it, what will happen to the K value? Or if I double it, stuff like that. So, yeah. Oh, I forgot to come back to you.
You just add up the total number of that molecule and then use that as the exponent. Use all the coefficients and change that to the exponent.
Yes. It should be a common change through the exponents, right? It's like they've all been doubled or they've all been halved or something, and then that becomes your power. Yep. So, any other questions? Okay, second thing we're going to talk about today is just a little slight twist on Rice charts. So those of you that most of the questions I had from our reading were just like, hey, can we do more Rice chart practice? Here it is. We're doing more. It has a little twist to it, but it will bring up hopefully some things that we were stuck on last time. Okay? So here's our first practice problem. Let's do this one together. So we have our equation. It tells us that a 0.1 mole sample of each of the 4 species in the reaction represented above is injected into a rigid, previously evacuated 1 liter container. Which species will have the highest concentration when the system reaches equilibrium? Now, once again, something we've got to make sure we do in this class, right, is sometimes we can be really good with a skill when it's like labeled on the worksheet. Like, hey, this is topic 7.7. I can do it because I know what 7.7 is about. But then when I give you the test and all the topics are scrambled and not labeled, I find some of you get very lost even though you've done problems like it before because you just forget what goes where. So what about this problem helps me identify the Rice chart's going to be beneficial?
Well, just a quick question.
Oh, yeah.
Do we need a Rice chart? Because we know it's, I think it's reactant favored, right? So it has to be one of those, and then just do, oh, this is 2 to 1, and then.
I'm going to do what you did in a Rice chart for those that need the visual, but in a sense, that's what you just did. Because the idea of a Rice chart is just comparing what we have at the start to the end, right? And so that's kind of the idea here is, okay, I have 1 mole of each initially, right? It may not say initial, but does everyone see how this is initial conditions? But then we want to know at equilibrium. So anytime you have beginning and you want end, but you don't have something, then the Rice chart is a great visual to help you see what's going on. So I'm just going to bring my reaction down here so I can write next to it. And set up our rice. And then what's the first thing you do with a Rice chart? Or question, Eli?
Well, okay, well, just thinking about it with like the numbers being in front of it, we have to times that with moles itself. So for example, with the 4 hydrogen atoms, you multiply that by 41 to get.
Ooh, I'm glad you bring this up. Initial does not have to match the balanced equation. The change is the only thing that matches the balanced equation. Because think of it like this, initially is whatever you pour in, right? And you don't have to pour in a 2 to 1 ratio. Now you could, that would save ingredients. But a lot of times you put it in excess, or maybe you're lazy and you just dump them in, right? So initial does not have to match the balanced equation, but that's a great thing to note because I think sometimes we forget and we think it has to match. So for initial, it would just be 0.1 all the way across. Now the difference from this problem from the ones we did last time is last time we were normally trying to find this value. This one is already given, and Ben, you interpreted it for us. What is this number telling us?
Reaction favored.
Good, so write that next to it, everybody. So always interpret a K when it's given, because it's there for a reason. Some information on the AP test isn't used, but honestly, most of it is. Like, they don't give you too much that doesn't have a reason for being there. So this reaction is reactant favored. So what that tells me is since they're all in equal amounts, what am I going to make more of to get to the right equilibrium? Good, so that means, that's telling me that these are going to decrease and these are going to increase. Now the catch is we don't know these values because that's what the question is asking. But you always know the change because it's a ratio. So I'm going to say, well, this one's going to decrease by something. We'll call it X. This one's going to decrease by 4X. This one's going to increase by X. And this one's going to increase by 2X. Good. Everyone see where I got those from? Because I don't have the bottom, so I can't fill it in with an actual number, so that's why we just use X's. Okay, now if I carry everything down, so we have 0.1 minus 2x, 0.1, oh, thank you, plus x, 0.1 minus x, and 0.1 minus 4x. Now we have a lot more math work if we had to actually solve for x, but the problem isn't asking for that, so that's good.
How would you
I'll tell you that. I haven't actually, in a later unit we will, in the equilibrium unit, your book has you do it, but I've never seen an A problem have you do it because it's kind of intense. But I'll show you just so you're aware. So all we want to know is which one's going to be the biggest.
So 2h.
Yep, so the answer is H2S. Because 0.1 plus x is going to be bigger than all these others, regardless of what x could be. So,
X was a negative.
can x be negative? No.
Challenge accepted.
So the way you actually would solve for x is you would plug these into the KC expression.
Like add all of them
Oh,
together.
then you can actually find
You don't have to write this down because I don't want it to give you nightmares.
it. Okay.
You probably already have given them.
But, so h is 0.1 minus 4x, and then that would have to be to the fourth.
Okay. Wait a second.
And then you have to solve for x.
So yeah,
I'm just gonna do this. This pops up.
and then you have to.
That would be so fun to solve.
See, I-
for x.
So you'd have to, yeah, you'd have
All that
to.
algebra.
It's a lot of algebra, that's what it is at that point. And then in the end, you'd probably have to, probably graph it would be my choice for solving for your final x.
Yeah, but like Chinese
You can zoom in on your graph too, so. But the times Calvin I've seen them have you do this, you don't have, it's not this complicated of algebra. It's a lot simpler, so. I think there's one on your homework where you do it, but once again, it's like, you just have like x over 2 or something like that.
That's too hard, sorry.
So, okay, questions on using x's in a Rice chart. Okay, for a smiley face, try this one with your table, buddy. Ready, set, go.
So it's basically saying zero is greater than.
You should feel so blessed, Macy.
I love your dearly.
When you have an answer circled, raise your hand and I'll come give you the thumbs up or the try again.
So can't be C or D because of that, right? Because it's product thing. So it has to be either A or B. Maybe I'm like.
You know initially that they.
Okay. So this is the weird part because you don't even need to do it right. It's like really CO isn't greater than, so it has to be A, right? Because it's 2H. Oh.
Yeah, they are the same.
Wait. Because it's not 2H, it's just things. No, look, I'm looking at it.
Because H2.
They should be equal if it's not 2.
Yeah, but it's changed.
I'm assuming it's A. I could be wrong here.
Yeah,
Definitely A or B. I'm sure it's A because think about it.
Like minus 4. So you write it's reactive favor if you want to. The value of the adding by that makes sense.
Wait, what?
The answer is 1.
The value. Okay.
It has to be like 10 times.
Wait, why am I looking at H?
Oh, so it's gonna be reactive. Yes. No, product favor. Over 1. Product favor over 1. Try to do over product. This computer programming is still are actually. Yes, it's concurrent enrollment. It counts for because so that's the thing. It's prop paper. It still counts. I still work and play games. I'm getting college credit. Why? And electronic like. Oh, so it would be because it is a lot of math. Like, but it's really so it would be yeah, it's all that
That H threw me off so hard.
or I guess yeah, I should do a secondary honors. If I like, if I
You're right. Oh yeah, that's what you're saying, you can do that.
Dude, I actually have my graph.
Calculator.
Oh, wow. Oh, yeah. Dude, you know another problem? OP intro. Yeah, I'm gonna take it.
I just use logic calculation right there.
And then I just get a yellow whatever it takes that. And I get credit.
So the problem doesn't tell you how much product you have, because you're not.
Talk CPA.
Organized on Friday.
Okay, eyes up here, everybody, and we'll walk through it, and you can check it with me if you haven't yet. Okay, so I plugged in now, reversing here. With these type of problems, and it's a pretty common AP type problem, you don't have to have the Rice chart. The Rice chart to me is just a visual way of understanding the ratios. And if you're having a hard time doing it, to me it doesn't take that long to set it up, and then I guarantee I pick the right choice, rather than second guessing and spending the same amount of time. Okay, but once again, the more you do it, you might be able to do it without using a Rice chart, and that's fine too. But don't ever be ashamed, if you feel ashamed, of writing more out if it gets you the right answer. Because that's way better than doing something in your head and being right some of the time, right? Okay, so we know these were 1. How do I know this is 0?
Because you're doing
Good, you gotta read between the lines with the product, right? If it doesn't say you're putting product in, you don't have any product to begin with.
Will those be 1 or like 0.5? Because the molarity, because it's a 2-liter container, will they be 0.5?
Great question, or great observation, Hannah. When you do the Rice chart, you actually want to use moles, not molarity. If we had to get to molarity, we would divide these by 2. But yeah, actually, this is a good thing to recognize. If a problem gave you molarity, you've got to change it into moles before you use the Rice chart. Because molarity is not additive. Molarity is not an additive property. If you take a 2 molarity sample and pour another 2 molarity sample, it doesn't make it a 4 molarity sample. But moles are additive. So, great observation. Okay, so now the change is based off the ratio. In this case, I don't have any product. So we know that the reactants are going away, so this is going to decrease by x. That would decrease by 2x, and that's going to increase by x. 1 minus x, 1 minus 2x, and x. And so then if you go through what must be true, is A true? No, this is not double, or this is not double that, right? Is B true? Is H2 always going to be less than CO? Yeah, because it's 1 minus 2x versus 1 minus x. It's always going to be true, right? So.
To figure out that it's product is favored, can you just say that 14.5 up there?
Yeah, so you could also use that. In this case, I didn't have to, because I knew some product had to be made because it's an equilibrium. But you also could have gone on the fact of, oh, the 14.5 tells me it's product favored, so I need more product, right? So you can also look at that as well. So, questions on that? Now, just to clarify, think in your head for a second, because we did rice charts last time and we didn't use X's. We did rice charts this time and we used X's. What's the difference? Like, when you read a problem, how do you know if you need to use X or if you don't actually have to use X's? Raise your hand if you have an idea. Jordan, what would be one thing?
If you don't know any of the equilibrium, then you use X's. But if you do know some of the equilibrium, you can figure it out from there and then use the ratio for all the other ones.
Good. So one time we use X is if you don't have any equilibrium values. Because yeah, she's totally right. If you don't have anything down here, then the only thing you do is throw in an X value, right? And then vice versa, if you're given initial and equilibrium values, then you'll be okay. Whoa, that M went crazy. Okay, Jordan, have some face that. Other connections of when and when not to?
It would have an X when it would state the final equilibrium, but if it didn't have an X, it would tell us to find them.
Good. If it gives you K, you're probably going to use X's. If you're finding K, don't use X's. The reason why I say this is what happens is sometimes students try to one path with the wrong problem and then you just get real stuck because you have all these variables and you don't know where to go, or vice versa. You don't have variables and you start making up numbers because you don't know where to go. So kind of just some things as we compare these two types. Once again, rice charts are huge with equilibrium, and equilibrium will continue on in other units as well. So getting familiar with how to structure these problems will be very beneficial. So, any other questions on that before we look at a slightly different type of problem? Okay, deep breath, let's look at this one. Let it out. Question?
So for the 800s, do you want to know
Yes, so put a third column over there. Yeah, that'd be perfect. Just write distance challenge. That'll be great. Thanks, Hunter. Okay, so this problem says a certain gas, XY, decomposes as represented by the equation above. A sample of each of the gases is put, I can't read that on that line, put into a container, and here's their initial pressures. Okay, so I throw in some XY, some X, and some Y into a container. These are the pressures that they have. The temperature is held constant, and we want to know which direction will the reaction proceed. Now, first off, let's decode what that question is asking. What does it mean, which way will the reaction proceed?
You mean like which is it favored? Like forward.
Kinda. Based off what's given, that KP, what does it tell me? If the KP is 230, what does that tell me? So this is a product favored reaction, right? Hannah, what were you gonna say?
So does it mean that it's like what reaction's gonna happen first? Like go forward first or backward first?
Yes, so it's like saying, okay, it needs to get to equilibrium. Now the catch here is a lot of people would look at it and say, oh, 230, product favored, it's gonna go to the products. The catch is, if we look at this, I'm gonna just bring it down here just so I can point to things. Well, not plus. So if I throw in the initial value, so that one is 0.01, this one is 0.2, that looks product favored to me already, right? Like there's more products than there are reactants. What we need is it isn't, in this case, it's not just about being product favored, but it's being product favored at 230 exactly. So we need to figure out the right ratio to get us there. So this is a case when you have initial conditions and then you're trying to figure out what it's going to do to get to equilibrium. This is where we're going to bring up the value of Q that we introduced last time. Does anyone remember what Q was? We really didn't talk about a ton, so it's okay if you don't, but There was a Q. No, we were so focused on K last time.
Reaction quotient.
Good job, Macy. Have a smiley face for that. Now flip back again.
Someone just like,
What's the setup for Q?
Like the QC,
Uh-huh.
QP in this case,
Uh-huh.
it's like the products over the reactants, right?
Yeah. So Q is the exact same setup as K. The difference is K can only be claimed if you're at equilibrium. Q, it can be any time at all. So let's plug it in. So products over reactants. So once again, same exact setup. Plug that into our calculators. I got an answer of 4,000.
Whoa,
Oh, that's my problem.
Don't forget the square. Okay, so as is, without these things doing anything, what does this mean?
way too product.
I'm too product favored, right? We want to be product favored, but 4,000 is way too product favored for this equilibrium. So for this system to get to equilibrium, what needs to happen? Yep, so this one needs to create more reactants. So there's a few ways you can say it, because it's too product favored, right? So to answer the question of which direction will the reaction proceed, you could say it's going to proceed to the reactants. You could say it's going to proceed to the left. Or you can say it's going to go in reverse. They all mean the same thing. Does everyone understand why it has to go to the left, though? So it can get to equilibrium, right? Because it's too big and we need to get it smaller. So we need to bring in more reactants.
So, since the 4,000 is too big, that means we have to go smaller. So if it were like 100,
I love how
would you
contagious
just say it's product favored stuff?
Yes. Yep, exactly. So in this case, because 4,000 was too big for what we were wanting, that's why it had to go that way. But if it was too small, then it would go the other way. Yep. Eli.
Can we just go straight from the initial pressure and like the KP? Can we just figure it out like that way, or is there like some circumstances where like won't? If that makes sense.
I'm sorry, not understanding the question.
Be fine.
So let's say, could you like solve this equation from just 230, or will there be like some situations where it won't be like that?
Well, to me, this is one of those situations because I've had students in the past with this problem. They just see, oh, 230 product favored, shift to the products. But in this case, I'm not shifting to the products, I'm actually shifting to the reactants. So yeah, the only way to really see is you've got to compare your Q to your K value. So, does that make sense?
if you did that equation on this test, but instead of a Q, you wrote a K, would you get dot points?
If you came to the right conclusion, I don't think so, because normally it'd be like 1 point only. But normally we just don't call it K because K is reserved for at equilibrium. So, okay, so here's our comparison, but good question, Sam. So if Q were to equal K, let's say you solve for Q and it equaled 230, what does that tell you?
You are at equilibrium.
You're at equilibrium. You got lucky with what you poured in and it's not going to change. Okay?
So good.
But if Q is less than K, meaning it needs to get bigger, what do I need more of?
More reactants,
So remember, K is products over reactants.
so more reactants.
So if I need it to get bigger, you need more on the top. So if Q is less than K, you need more products. It's a silly thing, but if it helps you, the little greater than or less than sign, think of it like a little crocodile, and it's going to go in the direction it needs to eat. Okay? And then vice versa, if Q is too big, well then you've got to make it smaller, so the only way to make it smaller would be more reactants. Questions on that? Okay, let's get one more smiley face for the day. Do this one with your table buddy first, smiley face. Ready, set, go.
We can do it this side.
All of these are 2 moles Wait.
Wait, it would be. Wait, okay. Do you have any idea? Okay, so it's gonna be this way, right? Right. Yeah, because it's product favor, it's not product favor. That. Do we just do right, like see right or left, or is there like more scientific?
No, like, yeah, you can say any, if it's a free response, you can say any of those 3 ways. You can say proceeds left to right, goes forward or backwards, or makes more products or makes more reactive. So I've seen it written all 3 ways.
Say east or west, I don't know which way.
Maybe not east or west, north or south.
Yes, that is the way.
Maybe
Draw a compass on your paper, and then you can say.
Got it.
northeastern on the lateral.
You write like the most confusing way to say go left.
Exactly. We're just gonna mark you right because they don't understand your answer.
And then you go in and you explain it to them in like, you should.
Yeah, I think when in doubt, the AP test scores wrong, sadly.
Also, is there any competition between you and your husband? You're facing off.
I know. Tomorrow we'll find out who won.
I think you may have won, but
That's what he said too.
You almost won that.
yeah, you're number 2.
It's true. It's true. Well, I was hoping they wouldn't put me and him against each other, and then we could like meet
Oh, that.
at the finals or something. That'd be
I'm
cool.
not sure anybody could beat Egbert though.
You think so? He's pretty into it, huh?
Yeah, he had all of his classes, so I was used to Ash's class, and she doesn't go to party to go to the
Really?
Yeah.
Why was she helping him?
I think they're friends.
Because of math? Because she's a math teacher?
Probably because they're friends. Yeah. So.
I'm Kylie's neighbor.
Oh.
We grew up together.
Wow, you need to confront her about that.
Tisk tisk. Okay, everyone ready? Everyone have an answer? Okay, take your finger and point in the direction it's going to shift.
Wait, you're right or?
Based on your, like, that's the equation, point, and how you're looking at it. Does that make sense? Okay, so we're going to the product side. So you said that, you can have a smiley face. So, 4. Okay, questions on using Q. Okay, last recap for today. So, once again, in thinking of a test that's blended with lots of different questions, what in a question will help you identify that Q is a helpful thing to use? If you're looking for the direction the equilibrium goes and you don't need an actual concentration value, use Q.
Interesting. So if we had like an equation and then we found out that K was equal to Q, would we just write at equilibrium?
Yep, then you'd say it's at equilibrium. So, any other questions?
So, isn't it like the majority of the time will it go to like which side is favored? So if it's product favored, it will usually go to product favored.
I don't know if I can say like all the time because it just depends on what you pour in, you know?
Yeah, but usually it's like you pour an equal amount, all.
If you pour equal amounts, well then yes, you wouldn't even have to do it, right?
Yeah, but who like pours in 1
That's what they wrote that question. Okay, here's homework 7.7, and then you have 1 AP classroom quiz and 3 pages 3.
Hey, how are you reading this?
For you the whole page.
didn't finish that as much
I know, I wish it's the way where like in class, we like to keep this like show more on there, so.
Oh, yeah.